Polyamides. First class we are going to discuss polyamides. Under this heading we are going to discuss how to prepare nylon 66 or 66 and nylon 6 and their uses. First of all, we'll discuss nylon 66. So if you look at the monomers or raw material used for the preparation of polyamides, this nylon 66, you can easily see this adipic acid is required. Adipic acid having two carboxylic acid groups, and you can see here, if you see here, there are 6 carbons. So in adipic acid, total 6 carbons present, and in fact this adipic acid is produced from cyclohexanone, or its oxidation, cyclohexanone. So oxidation, after doing the oxidation reaction of cyclohexanone, we can have adipic acid. This is another part you need not to remember. Only you have to remember that there are 6 carbon included in this monomer, and at carbon number 1 and carbon number 6 having COOH group. This is how 6 carbons there. Now in case of this hexamethylene diamine or 1,6-diaminohexane, because at 1 and 6, 2, 3, 4, 5 and 6 carbon, we have 2 amino groups. Because of that we call it as a 1,6-diaminohexane. So it is also having 6 carbon. Now both monomers having 6 carbon, and because of this we called it as a nylon 66. Now what happens, as I mentioned earlier, this is a stepwise polymerization reaction. So first step you can see here, because of lone pairs present on amino group, this is a base and this is acid. So there is acid base reaction, so obviously proton will transfer. So this proton, these 2 protons will get transferred to this amino, means to this base amino group, and as I mentioned here, by using this lone pair is used to join this proton, and because of that we get positive charge developed on this nitrogen. And when we remove proton from this carboxylic acid group, we get these 2 anions. So in fact this kind of proton transfer reaction takes place here to get 2 ions. Now after that elimination takes place. Elimination means we have to just remove water molecule. For water molecule we need H2O. So the 2 hydrogens are actually taken. I am showing from this diamino compound. So you have to break them H2O to prepare H2O from both ends. So here also it is assumed that another this 1,6-diaminohexane is there, and n number of molecules. Repeatedly I am taking adipic acid as well as 1,6-diaminohexane here. Due to lack of space we cannot take it, but we have to consider it. Now once this kind of water is eliminated from both ends, repeatedly that is taking place from both monomers, and if you look here at 6 carbon of adipic acid and first carbon of this hexamethylene diamine, you can say even hexamethylene diamine. So there is a formation of amide linkage. So this is amide group, CONH. So this amide linkage is formed, and because of this you can see here in this polymer this functional group is repeatedly coming. So this is called polyamide, poly and amides. So you can see here this zigzag line means you can repeat that portion, this portion again, after green, blue, and after blue, green portion you can repeat. But due to lack of space, I have written here zigzag, means that portion is repeated. So this is called nylon 66, and it's very useful polymer. It is used for the preparation of for making certain clothes. You can make parachute, airbags can be prepared from nylon 66, or seat belts tents can be prepared and even fish net can be prepared. And when you compare the properties of nylon 6,6 and nylon 6, I think nylon 6,6 is quite better than nylon 6. Second example of polyamides is nylon 6. So this nylon 6 is prepared from caprolactam. So you just watch carefully the structure of caprolactam. So this is cyclic amide having 6 carbons, 1, 2, 3, 4, 5 and 6. And to the 6th carbon there is a NH group. So total 7-membered ring. Caprolactam is a 7-membered ring. And if you remember, we can prepare this caprolactam from cyclohexanone. This is cyclohexanone. So cyclohexanone is treated with hydroxylamine, or you can say, if you remember, we prepared this by using Beckmann rearrangement. So by using Beckmann rearrangement, so we can prepare caprolactam, which is 7-membered ring. You need not to remember this, but I am just telling you the background of how to prepare caprolactam. So you remember only 6 carbons and 1 nitrogen. So this caprolactam is a cyclic amide. In aqueous solution, it undergoes hydrolysis, and once it undergoes hydrolysis means what? If you see here, OH is going to join here to break this bond, and EH is going to join here to form this NH2 group. So we get here 6 amino. It is having 6 carbon, 3, 4, 5 and 6. At 6th position amino group is present, which is formed after the hydrolysis of caprolactam. And we get now 6 amino hexanoic acid because 6 carbon. This 6 amino hexanoic acid again reacting with fresh molecule of caprolactam, or you can say it is reacting with this 6 amino hexanoic acid. 1, 2, 3, 4, 5 and 6. This 6 amino hexanoic acid which is produced from caprolactam. And once this is produced, you have to just remove water molecule. So OH is removed and H2 or H will be there. 1 H is taken from here and we get here H2O molecule. So this H2O is removed. So what left there? So NH and CO. NH and CO. This NH and CO is formed. This is amide. So because of this amide is repeated number of times, we call it as a polyamide. And this zigzag line means what? This unit is repeated from this side with carbonyl group, and this zigzag line means this unit is repeated with NH group. So in this way we can prepare nylon 6. It is also called Perlom. It is actually its trade name. And I have selected only 2 applications. It is used for making rope and tire cords, vehicle tires, tire cords. So we prepared rope and tire cords from nylon 6. Why we call it as nylon 6? So this 6 indicates 6 carbons present in a monomer. So this is difunctional monomer, difunctional group. There are 2 functional groups present in this monomer, and this monomer is prepared from caprolactam. Again, this caprolactam is prepared from cyclohexanone by Beckmann rearrangement. So this is all about polyamides, and we have discussed 2 examples. Thank you.